Alright, and welcome to our Solving Absolute Value review. So for number 1, it says solve for the values of x that make the equation below true. So this is actually going to be a level 3 problem, and we know it's a level 3 problem because we have our absolute value bars, and then we have some things multiplied and added on the outside, but we still only have one thing on the right hand side. So the trick here is that we want to get these absolute value bars by themselves. Well, in order to do this, I have to get rid of the multiplying by 3 and the plus 8. So the question I would ask you is, what do we always get rid of first, addition or multiplication? And we want to get rid of the addition. So the opposite of plus 8 would be minus 8, and that's a 0 pair. So now we have 3 absolute value, x minus 4 absolute value equals 17 minus 8 is 9. Now from here, you cannot distribute the 3 through the absolute value bars. So what you have to say is, like, how do I get rid of the multiplication? And of course, the opposite of multiplication is division. So we'll divide both sides by 3. And then I'm actually going to bring this right up here, and we're going to say this. The absolute value of x minus 4 is equal to 9 divided by 3, which is 3. Now I want you to pause the video, finish taking notes, because I need a little bit of room here. Okay, so we have the absolute value of x minus 4 equals 3. Now what we're going to do here is, remember, we don't know if this quantity on the inside is actually equal to a positive 3 or if it's equal to a negative 3, because absolute values always produce positive 3's. So this is where we're going to do the split and write out our two equations. Over here we'll have our negative equation and our positive equation. So for our negative equation, we have x minus 4 is equal to negative 3, meaning we make this whole right side negative, and over here we have x minus 4 is equal to positive 3, and notice nothing changes. Okay, so over here to get x by itself, I do plus 4, and I get x equals positive 1, and over here I do plus 4, and I get x is equal to 7. And there we go. There are my two solutions. Now remember, we always want to test these out. So let me come over here and write x equals 7. Let's clean this out. Let's do a very quick test. Okay, usually if I want to find the extraneous solution, usually it's going to wind up being your negative solution. And so let's just, but let's just try the x equals 7, which was our positive solution. So we have this. We have 3 absolute value. Instead of x, I write 7 minus 4, close absolute value, plus 8 is equal to 17. Okay, so we're not going to solve. That's silly. What we want to do is simplify. So I now have 7 minus 4, so the absolute value of 7 minus 4 is the absolute value of 3 plus 8 equals 17. And here, the absolute value of 3 is just, well, still positive 3 plus 8 equals 17. And of course, 3 times 3 is 9. 9 plus 8 actually does equal 17, and if you can agree that that's a true statement, would say, you know what, this is in fact a solution. Okay, and it turns out if you plugged in the 1, you would get that it was a solution as well. So this graph actually has two solutions, 7 and positive 1. All right, let's move on to our second example. Okay, for example 2, notice that our inequality is 2 absolute value x minus 4 plus 8 is greater than 24. It's an absolute value inequality, so this is going to be a little bit different. Now, the other thing I want you to notice is go look at number 6. Go look at number 6. It actually looks like the exact same problem, with the exception of, instead of a greater than symbol, it actually has a less than symbol. Okay? So be very careful that you don't think, oh, Mr. Hastings made a mistake and he did them the same. No, I actually did this by design because I want you to see the different possibilities. All right, so for this one, whenever we have 2 is greater than x minus 4 plus 8 is greater than 24, what we would like to do is still go ahead and get our absolute value bars by themselves. Okay, so let's see here. We can do minus 8, and we'll get 2 absolute value, x minus 4, close absolute value, is greater than 24 minus 8, which is going to be 16. And then from there, we can divide both sides by 2, and now we have the absolute value of x minus 4 is greater than 16 divided by 2 is 8. Now, this is where it's going to be a little bit tricky because there's actually two different ways that you have to memorize. Two different ways. And so we're going to start with this very first way. So let's say something like this. Let's say x plus a, the absolute value of x plus a is greater than c. All right, greater than c, some sort of constant. Okay? How in the world do you split this inequality? Well, when it's greater than c, you actually split it kind of in the traditional way, but you write two things. You write x plus a, get ready for this, is less than negative c, and you write x plus a is greater than c. So you have one, like you can think of this as the positive side, where everything stays the exact same, but then you have the negative side where your inequality has to flip and our c value becomes negative. All right, and it's okay to have a negative one here. So let's kind of look at these two different options. Okay, so when we go to our negative side, we're going to write x minus 4. I flip my inequality and write negative 8, and I'll just do a dashed little line here. And I write x minus 4, and I keep everything the same for the positive side of things. And from there, it's pretty easy solving. We just say, okay, well, x plus 4, and I have x is less than negative 8 plus 4 is, of course, negative 4. And over here, I write, let's see, x minus 4 is greater than 8. I do plus 4, and now I have x is greater than 8 plus 4 is 12. Now for these, I actually always want you to graph them so you have a really solid understanding of what this looks like. So pause the video, finish taking your notes. Right now, pause it. Okay, you're back. And so let's go ahead and see, like, how in the world would you actually graph these two solutions? Well, we just draw our graph. And we pick both these points. I know negative 4 is going to be on the left, and positive 12 is on the right. We just say 0 is somewhere in the middle. And then from here, we always circle both of them. Now notice this is less than and greater than. It's not less than or equal to. It's not greater than or equal to. So we keep these as open circles. And less than negative 4 means we're shading everything to the left, and greater than 12 means we're shading everything to the right. So if I were to ask you for any solution to the problem, well, it's going to be somewhere on these arrows. So for instance, negative 10 is less than negative 4. We could say x equals negative 10. That would be a perfectly good solution. We can choose any number greater than 12. We could say, you know, what if x was 100? Yeah, x would equal 100. That would also be a solution. What would be a non-solution, something that wouldn't work? Well, 0. X can't equal 0 because that's going to give us an untrue statement. Okay? All right, let's go ahead and move on to our next example. Okay, y'all. In my opinion, this is one of the most difficult problems. This is what we would consider a level 4 problem, and we'll consider it a level 4 problem because it has two terms on the other side of the absolute value equations. So let's go ahead and write this out. So we'll say, okay, we have the absolute value of 3y plus 15 is equal to 3 minus 9y. Now, we're going to have to do our split, okay? And over here, let's write our negative version, and let's write our positive version. And y'all, the positive version, I cannot stress this enough. It's so easy because it doesn't change, okay? Let's put an S in there for doesn't, but yeah, it doesn't change. So I can literally copy this as I see it for the positive version. 3y plus 15 equals 3 minus 9y. Now what about on the left? Well, on the left, my negative version definitely changes. So we still keep the 3y plus 15, but where it changes is I have to make this whole right side negative. So everything on the right, this 3 minus 9y, the whole thing is now negative, and let's distribute that negative. So now I have 3y plus 15 is equal to negative 1 times 3 is negative 3, and negative 1 times negative 9 is positive 9y. And so from here, I can now solve both of these. What should I move first, my variable or my constant? Well, when I have a variable and a constant on both sides, we always want to move our smaller variable first. Let's do minus 3y, minus 3y. Okay, that cancels. Now I have 15 equals negative 3, and 9y minus 3y is plus 6y. And most of you can solve that from there. That's pretty straightforward. We know we're going to do plus 3 and plus 3. I'm just going to have to really squeeze that in. 15 plus 3 is 18, is equal to my 0 pair and then 6y. And most of us know this. To get rid of the 6 in front of the y, we have to divide. So we just divide both sides by 6, and 18 divided by 6 is 3. There is one of my solutions. All right, let's go ahead and solve the easier one over here in red. I'll look at both my y's, but notice now we have a negative 9y on the right. That's the smaller y, so let's do plus 9y plus 9y. And y'all, 3y plus 9y will be 12y plus 15 is equal to 3. And from here, we just continue to solve for y. So I can do minus 15, minus 15. Oh, this comes out pretty nice. We have 12y equals negative 12y. And we can divide both sides by 12. And let's get this. Y equals negative 1. Now, here's what I want to do, because we really want to test out both solutions. I'm going to write y equals negative 1, and I'll write y equals 3. And I want you to pause the video and finish taking your notes. And let's go ahead and see what it looks like to test both solutions. Okay, so here's what we're going to do. We're going to test both of these solutions. Let's test out y equals negative 1, and let's test out y equals positive 3. Okay, so over here, what I have is in my original equation, I see 3 times y plus 15, close the absolute value, is equal to 3 minus 9 times y. Over here, I'll do the same thing. The absolute value of 3 times y plus 15, close absolute value, equals 3 minus 9y. Okay, so let's go ahead and plug in our first solution. Let's plug in that negative 1 and negative 1. And let's work it out. Okay, back to my red, or I'm sorry, back to my blue. So we have the absolute value of 3 times negative 1 is negative 3 plus 15 is equal to 3, and negative 9 times negative 1 is positive 9. Okay, and now I have negative 3 plus 15, which is 12, and 3 plus 9, which is 12, and we can all agree the absolute value of 12 is, in fact, positive 12. So I know that y equals negative 1 is, in fact, my solution. It's one of my solutions. Now let's go over here and test out our other one. Let's test out this positive 3. Positive 3. Okay? And so I'll say, okay, we have 3 times 3, which is 9, plus 15. And over here we have 3 times negative 9 times 3 is negative 27. And wait a second, 9 plus 15 is 24. But 3 minus 27 is negative 24. And I want to ask y'all, can absolute value bars produce a negative? And hopefully you said no. Absolute value bars make everything positive, not negative. So in fact, y equals 3, it works out mathematically, but it's actually not a solution. And so what we call this is our extraneous solution. And more often than not, you will usually have an extraneous solution when you have a level 4 problem. Whenever it's set equal to 2 things, you really want to be diligent and test out both of your solutions. All right, let's go ahead and try one more example, because I want to show you an example of an inequality where it's less than. And it's going to look wholly different from anything we've done so far. Okay, so let's take a look at number 4. And I told y'all we were going to look at an example of an inequality that had a less than symbol, but you're probably thinking, Mr. Hastings, that has a greater than symbol. Well, I want you to think right now, pause the video and ask yourself, why would this inequality flip? See if you can come up with the answer before we start the problem. Alright, so let's go ahead and test it out together. We can see that this is an inequality, and it's very similar to a level 3 problem. So what we have to do is we have to go ahead and get these inequalities, or these absolute value bars, by themselves. So what is the opposite of minus 6? Well, we can do plus 6 and plus 6, and let's drop everything down. Now I have negative 3 absolute value bar, 2x plus 4 absolute value greater than or equal to negative 18 plus 6 is negative 12. Now you might even be thinking here, well, why isn't this no solution? Isn't this absolute value kind of equal to a negative? Well, two things. One, You can't ever make that determination until you get these absolute value bars fully by themselves. And two, we're never going to have an answer that is no solution when dealing with inequalities. Inequalities are different from equations. Now, how do I get rid of the multiplying by negative 3? Well, I divide both sides by negative 3. And wait a second, hold up. What happens when you divide by a negative? Your inequality is going to flip. And negative 12 divided by negative 3 is positive 4. So even if this was an equality, you still, once you get the absolute value bars by themselves, you still wind up with a positive number. So this one would definitely be, definitely would have solutions. Okay, so this is where it gets different. So this is where I want to give y'all another rule. Whenever you have something like the absolute value of x plus a is less than, so this is different, less than some constant c, all you do is you copy the x plus a is less than c, and then on the left hand side you put another less than symbol and you put a negative c. Okay, so this is going to be the rule for whenever we have a less than, and you are going to have to memorize this. Alright, now let's go ahead and split this up, or I'm sorry, let's go ahead and rewrite this. So we're going to rewrite this as 2x plus 4 is less than or equal to 4, but then we add our less than or equal to symbol on the left and we make it a negative 4. And this will be the first time that we've really seen something like this where we actually have two inequalities. And the way that you do this, I believe this is called a conjunction of inequalities, is we want to go ahead and still solve this like 2x plus 4. We want to get x by itself. We'll say, okay, well, what gets rid of a plus 4? Minus 4. But now we say what we do in the middle, we have to do to both the right and the left. So you actually perform three operations here. Negative 4 minus 4 is negative 8, is less than or equal to 2x. We have our 0 pair. Less than or equal to 4 minus 4, which is 0. And now we divide everything by 2. Will our inequalities flip? And the answer should be no, because we're dividing by a positive. So negative 8 divided by 2 is negative 4, is less than or equal to x, is less than or equal to 0 divided by 2 is 0. And from here, we can actually graph this by drawing our number line. Let's put these two values. Here's negative 4, here's 0. And we circle them. Let's switch colors here. And because it's less than or equal to, we have these lines underneath. We actually fill these circles in. We fill them in. And essentially what we're saying is x is in between negative 4 and 0. So we shade the space in between. So if I said, hey, what is a solution? Well, you tell me that a solution is any value in between negative 4 and 0. So for example, negative 2 would be a solution. What if I asked you for a non-solution? Well, anything greater than 0. So for example, 3, that is a non-solution. Anything less than negative 4, so something like negative 10, that is a non-solution. Alright, I hope this video helps, and I'll see you in our next review.